Hey everyone, welcome back to the channel. Today we're diving into the world of networking with a focus on the OSPF protocol. Let's break it down and see how it works. Before we dive into OSPF, there are some key concepts we need to learn first. OSPF Open Shortest Path First is an IP routing protocol that uses a mathematical algorithm to calculate the most efficient path to direct traffic on IP networks. OSPF is an open standard, designated by the Internet Engineering Task Force, IETF, as one of several interior gateway protocols, IGPs, within the family of TCP/IP protocols. Acting like a GPS for networks, OSPF helps routers communicate with each other, efficiently finding the quickest and most reliable routes for data to travel. By dynamically updating its routing tables, OSPF adapts to changes in the network landscape, ensuring that data reaches its destination as swiftly as possible. OSPF, Open Shortest Path First, uses Dijkstra's algorithm to determine the shortest path to each node or router in a network. Here's how it works. 1. Topology map creation. Each OSPF router gathers information about the network structure, links, costs, and creates a link state database, LSDB, which is a map of the network. 2. Running Dijkstra's algorithm. The router applies Dijkstra's algorithm to the LSDB to calculate the shortest path from itself to all other routers in the network. 3. Building routing table. Based on the shortest paths found, OSPF builds its routing table, which determines the best path for forwarding packets to each destination. This ensures that routers can efficiently route data based on the current network topology and link costs. To configure OSPF effectively, you need to grasp essential concepts like subnet mask, wildcard mask, as these are vital for seamless network operation. Behind 192.168.1.0/24, you can see it says 000 to 255. This is not a subnet mask. This is a wildcard mask. The subnet mask is 255.255.255.0. A wildcard mask is a reverse subnet mask. Let me give you an example. Let's head into the configuration and make adjustments. I will show you how to design a network topology using Packet Tracer. Here, we are adding the serial port. Here, we are changing the router's name to make it easier to identify in the network. Here, we will organize our work so we can better understand our network. We will configure the ports to ensure proper network communication. In this case, we have 3 ports to configure for proper network functionality: 1 gigabit Ethernet interface and 2 serial interfaces. We use the no shutdown command because it activates the port. We can see that the port is up. We will repeat what we did on the first router for all the other routers. We have finished configuring the ports. We'll start configuring the OSPF protocol. First, we enter the command router OSPF and choose any process ID number we want. Second, we enter the router ID command to assign a unique identifier to the router. Third, we enter all the networks connected to the router, followed by the wildcard mask for each network and the area number. Now, we will configure OSPF on all the other routers. Now, we will test our network by entering the command show IP protocols. We will see that this router recognizes all the other routers that have the OSPF protocol. We enter the command passive interface because this interface does not participate in the OSPF protocol. This router knows all the other routers. We enter the command show IP OSPF neighbor when we want to see the routers connected to this router. In this case, this router has two neighbors. In this case also, this router has two neighbors.